The material that we're covering today is actually very brief, so shouldn't be anything that should be too taxing. We're taking on the idea of continuity. Now, probably when you were dealing with continuity in Algebra 2 or earlier subjects, you got this idea that a curve was continuous if you could draw the entire curve without lifting your pencil. And in R2, or 2 dimensions, that definition holds and works fairly well, because the definition of continuity and the definition of connected tend to be in agreement in 2 space. However, as we branch off later on into some higher levels of mathematics, these 2 ideas are not going to be the same. This is going to be a particular issue if we continue into multivariate or advanced calculus. For the most part, this idea of not lifting your pencil will hold, but it's not a very technical definition. So we're going to give a more technical definition of continuity here. So we're going to pick an x value. We're going to call it a, and a is going to be a real number. Okay, so I'm going to put definition over here, and I'm going to build graph over here a little bit. So I'm going to work with, here's my x-axis, and I have some value a. Now, if a is a real number and f of a is equal to the limit as x approaches a of f of x, okay, so I have some function f, right? And this value here would be f of a, right? And in this case, if I come at a from the left or I come at a from the right, it appears that I am approaching that value. So this is a case where f of a and this limit have the same value. Whatever f of a is, that's that value. Okay, so if this is the case, then we say that f is continuous at a. Okay, or when x equals a. So this gives me the idea of being continuous at a point, right? So this point of the function is continuous. Now, that doesn't say I have a continuous function. It says I have a function that's continuous at a point. So now I'm going to continue the story a bit. So if f of x is continuous for every x on the open interval from a to b. Okay, so let's think for a minute. Why does this have to be an open interval? Because the limit has to exist, right? So if it's a closed interval from a to b, then I don't have a limit as I go from the left of a or the right of b. So the limit at a and the limit at b doesn't exist, and thereby this definition of continuous would fall apart. So this always has to be on an open interval. So if f of x is continuous for every x on the open interval a to b, then we say that f is continuous on AB. Okay, so if f is continuous at every point along the interval, then f is continuous on the interval. Now note, the interval negative infinity, infinity, is an open interval. So it is possible for f to be continuous everywhere. And then we would just say that f is a continuous function, or f is continuous on all the reals. Okay, so quick summary. Continuity is basically defined as the limit is the same as the functional value. If I have that, then I'm continuous at a point. If I'm continuous at every point on an open interval, then I'm continuous on the open interval. If that open interval is negative infinity to infinity, then I have a continuous function.